So I want to make a little video. It's probably going to be a kind of a long video on how to balance equations. This is question 2 in the pre-lab, and it's how to balance redox reactions in basic solutions like the one in the lab. And this is section 20.2 intro. It also goes back to chapter 9, but something we haven't talked about very much. So I'll just walk you through this step by step. And so the first step is to break this into what are called 2 half reactions. What is being oxidized and what is being reduced? And that's this first step. So we have an I minus, and that I minus is becoming I2, and this has a charge of -1, right? That's what halogens have, and this is an element in its elemental form, so that's a charge of 0, a redox charge of 0. So this one must be gaining an electron to do that, and when ion, atom, molecule accepts electrons like this, this gives up electrons. It gives up electrons. It loses an electron to become the element, the neutral. That's called oxidation. And in the other molecule here, ClO minus, that is becoming Cl minus. Now, the rules here, going back to chapter 9, is that oxygens always carry a charge of 2 minus. That's the charge. They're in group 6, 2 minus. Now, chlorine can change, though, in these redox-type reactions in a molecule like this one. So it would have to have a net charge of -1, and that means the chlorine must start out as essentially +1, right? +1 plus a -2 gives us the total of -1. So Cl starts as +1. It becomes a -1. And to do that, it's got to pick up electrons, 2 electrons, to change its charge from +1 to -1. So it's going to pick up 2 electrons to do that. Now what I'm going to do is follow example 20.3 in your textbook. That's all I'm doing is following example 20.3, going through the steps required in this basic solution. And the first step, so that's the first step, right, to recognize what's being, so this is what's being oxidized. So oxidation. And this is being reduction. This is the reduction reaction. Okay, but now we've got to balance materially, right? So I've got I minus, and it is becoming I2. And of course that means I have to put a 2 there. And this is ClO minus, and that's becoming Cl minus. We're not worrying about the O right now. We're just balancing the atoms that are there, and they balance. So that's the first step. So that's our first step, balancing materially what is there. Now we have to account for this O. So we'll do this again, our second step. When we have to account for an oxygen, we do that by adding water. So here we have ClO minus. This becomes Cl minus, and to account for that O, we add an H2O. So materially first, balance what's there, and then in the second step, when oxygens need to be added, they're added in the form of water. Okay, so I've just now brought this forward to this clean sheet because I'd run out of room on the other side. This is where we're at. We've added our water to balance our ClO. I mean, actually just the O. Now, in doing this redox reaction in basic solution, to balance the water we've added, so 2I minus I2, that's nothing necessary in that first half reaction. But here we've got H's on this side. To balance those H's, ClO minus, we add H pluses. So 2 H pluses to this side is Cl minus and then plus H2O. Now that takes care of the H pluses, doesn't do anything about the O's yet. That's our next step. So we've got to balance the O's. I'm sorry, what I meant to say is we've got to balance the H pluses. Well, we've got to neutralize the H pluses. We do that because this is being done in basic solution by adding OH minuses. So I just want to keep this clear. That's our step. Here's our second step. Now we're at another step here. So we've got our 2I minus. We've got our I2 here. We've got ClO minus here. We've got plus 2H pluses. And we've got Cl minus plus H2O. And to neutralize these H pluses, we add OH minuses. And we have to add 2. Okay, so we need 2 there. So I'm going to put a 2 there. I should have drawn in. Got to add on both sides in this case. 2 OH minus to both sides of the equation to keep that balance. And then we can gather and make water. So ClO minus, this makes 2 waters. Gives us Cl minus over here plus H2O plus 2 OHs on this side. Now the last step, so that's another step, and I'll just draw a line through there saying that this is now what we have to deal with. And now our last step, well, not the last, but we now need to balance charge. So we have 2I minus here. That's 2 minuses on that side, so we've got I2 here, and that means we've got to add 2 electrons there to balance our charges. And then down here we've got ClO minus plus 2 H2Os, and that gives us Cl minus plus H2O plus 2 OH minuses. So we've got 3 minuses on the right-hand side of this one, only 1 over here, so we've got to add 2 electrons. Now, in this case, we balance, right? We've got the same number of electrons, and that's what has to happen. But if you didn't have the same number of electrons, you'd have to multiply the entire equation by a number that would make the electron charges balance, because they don't appear out of thin air. We produce 2 electrons on one half reaction, 2 electrons in the other have to be there in the other half reaction. Okay, and then now the rest of this is adding them together. So we're going to add these 2 half reactions together. So I'll just bring everything down, 2I minus plus ClO minus plus 2 H2Os. Now I'm not going to add the electrons because I've already balanced and canceled those out. Gives us I2 plus Cl minus plus H2O plus 2OH minus. Now we're going to cancel those out. So that cancels that water, and there's a 1 left there. ClO, 2OH minuses, that's got to be a minus there. All right. I just don't have enough space to put that in. And that really is our balanced equation then. If you can see that, it's going to be 2I minus plus ClO minus yields I2 plus Cl minus plus 2OH minus. We've got 3 negatives on one side, 3 negatives on the right side. The material balance is there. Everything charges. So that's how you balance these redox equations in basic solution. You got to remember there's an H2O in here. I just want to make sure that's in there. So see if I can sneak this in here. So 2I minus plus ClO minus plus 1H2O. Yeah, it gives me my I2 plus Cl minus plus 2 OH minuses. And that's it. A balanced reaction. So I'm going to draw a line through there so it's no confusion. I know it's messy, but that's balancing the reactions.